All right, people. I believe everybody's doing great, nice, and absolutely fine. Welcome, welcome, welcome. Okay. So, my dear NEET aspirants, we have this session over here, Save Physics, one last session. I would want you guys to smash the like button first and mark your attendance because this session is going to be extremely important for all the NEET aspirants out there who are supposed to write the NEET 2026, Re-NEET 2026 examination, that is day after tomorrow. And my dear NEET aspirant, at this moment, if you are a serious NEET aspirant, having anxiety at this point of time is very much normal. Okay? Do not panic. This is completely normal if you are having any sort of anxiety, if you are having any sort of pressure. It is because of the studies only. Okay? Our job is to give 100%. That is we are going to give. Okay, so my dear NEET aspirants, let's dive into this particular session. Make sure you smash the like button because liking the session is mandatory. And the session will be for 1 to 1.5 hours, 1.5 hour maximum. And it will be to the point. There will be a small concept and then we'll move on to the problems. Small concept, then we'll move on to the problems. Okay. So boys and girls, let's smash this Re-NEET 2026 day after tomorrow. Paper is not going to be tough. For sure, it will be between, I would say, moderate and tough. It will be between, it will be around moderate level only. Keep that thing in your mind. Now, boys and girls, the very first concept that we need to understand over here in this particular topic, that is work energy theorem. Work energy theorem is very important when it comes to the NEET examination. This is considered to be one of the important topics out there. Now, boys and girls, listen to me very carefully. What does work energy theorem actually say? We say, according to this theorem, according to work energy theorem, it says work done by all the forces is equal to change in kinetic energy. That's it. Directly remember, work done by all the forces is equal to change in kinetic energy. You can write it like this also. Work done is equal to change in kinetic energy. That means kinetic energy final minus kinetic energy initial. Okay. And then, my dear NEET aspirants, you can write it like this also. 1 by 2 m is mass, V final square minus V initial square. So ultimately, we'll be solving the questions on this only. 1 by 2 m is the mass of the particle, V final is the final velocity of the particle minus initial velocity square. This is going to be the work energy theorem. Let's take a look at the first question which was asked in JEE 2026 on this work energy theorem concept. Now take a look. A body of mass 1 kg, mass of an object is given as 1 kg. Is moving along a straight line. It is moving along a straight line with the velocity. Velocity of the body is given as, that is 2x square. The work done by the body during the displacement x is equal to 0 to x is equal to 5. So body has traveled from, let's suppose, x is equal to 0 to x is equal to 5 meters. We are supposed to find work done in this particular case, my dear NEET aspirants. Boys and girls, I'll be using work energy theorem. That is 1 by 2 m. M is mass, V final square minus V initial square. Because mass I know over here, final velocity and initial velocity also I can calculate. So final velocity will be when x is 5. I would say when x is 5 meters. So velocity final is going to be, put x is equal to 5 over here. 2 into, I would say, 5 square. 5 square is 25. So this is going to be 50. Okay. And then I say at x is equal to 0, what is going to be the initial velocity? That is 0, because if you put 0 over here, it will become 0. So work done, my dear NEET aspirants, is going to be 1 by 2 m. What is mass? Mass over here is given as 1 kg. Final velocity square, that is 50 square. minus initial velocity is 0. 50 square, 2500 divided by 2. So that is going to be 1250 joules in this particular case. So 1250. Direct. Work done by all the forces is equal to change in kinetic energy. So 1 by 2 m V final square minus V initial square. This is what you guys are supposed to remember over here. Is that clear? Guys, smash the like button if you are not like the session. Come on, do it quick, 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 quick. Then, my dear NEET aspirants, you have got one more question on the same concept, which was asked in JEE 2026 once again. This concept was also asked in JEE 2026. A body of mass 2 kg, there is an object which is having the mass of 2 kg. Moving along x direction, such that its displacement as a function of time is given by. Its displacement is given as alpha t square plus beta t plus gamma. Alpha t square plus beta t plus gamma. Where alpha is given as 1, beta is given as 1 and gamma is given as 1. Can you put it over here? So x will come out to be, put alpha 1, so it will be t square plus, put beta 1, it will be t, put gamma 1, it will be 1. The work done on the body during the time interval t is equal to 2 to t is equal to 3 seconds. We have to find the work done from t is equal to 2 to t is equal to 3. Now, first of all, let's find velocity over here. Velocity is going to be differentiation of this dx by dt. Now tell me, what is the differentiation of t square? That is going to be 2t. What is the differentiation of t? That is going to be 1. What is the differentiation of 1? That is 0. Now guys, we have to find work done from t is equal to 2 to t is equal to 3. I would say at t is equal to 2 seconds, initial velocity is going to be, put t is equal to 2. 2 into 2 is 4. 4 plus 1 is 5. 4 plus 1 is 5. Initial velocity is 5 meter per second. If I say at t is equal to 3, final velocity is going to be, put t is equal to 3 over 2 3s are 6, 6 plus 1 is 7 meter per second. Okay. Now, my dear NEET aspirants, if I say I use work energy theorem, that is going to be 1 by 2 m. Then I would say V final square minus V initial square. I would write over here work energy theorem is 1 by 2, 1 divided by 2 m, mass. Boys and girls, what is the mass of the object? That is given as 2, because 2 kg over here. Then final velocity square, that is going to be 7 square minus initial velocity square, that is going to be 5 square. So 2 and 2 will be cancelled. So work done will be 49 minus 25. Okay. So work done in this particular case is going to be 24. I hope this is crystal and clear. Next concept, my dear NEET aspirants, power. Questions have been frequently asked from this topic also in your NEET as well as in JEE. Now guys, see. We say power is simply work done upon time taken. How much work has been done in the given time? Let's suppose there are 2 people. Okay. One person is doing the same work in less time. Another person is doing the same work in more time. So the first person is having more power. Second person is delivering less power. Power is simply work done upon time. Now, what you guys are supposed to remember here, power is basically, I would say, F dot B. Dot product of force and velocity gives you what? Power. And F dot B is also equal to FV cos theta. This is basically the formula of power. Now, my dear NEET aspirants, for a system with varying mass, if there is a system with varying mass, whose mass is changing, like rocket is going up, its mass is changing, its power will be equal to this, V square dm by dt. V square dm by dt. So these are the 2 formulas on which you guys are supposed to solve the question. Take a look at the first question. This was the question asked in NEET 2023. A particle with the moves with a velocity. There is a particle, it is moving with a velocity. This is a particle, it is moving with a velocity. There is a particle, it is moving with a velocity. V is equal to, it is given as 5I cap minus 3J cap minus 3J cap plus 6K cap plus 6K cap. Horizontally under the action of force. Horizontally under the action of force. That is 10I cap plus 10J cap plus 20K cap. The instantaneous power supply to the particle is, power supply to the particle is F dot V. Power supply to the particle is F dot V. Power supply to the particle is F dot V. Power supply to the particle is F dot V. Now guys, I would write over here, how do you do the dot product of two vectors? Coefficient of I over here, coefficient of I over here, multiply the two. So 5 into 10 is 50. Okay? Yes. Then my dear NEET aspirants, 3 into 10 is 30. Then my dear NEET aspirants, 6 into 20 is 120. Now tell me, 120 plus 50 is 170. 170 minus 30 is 140. So power will come out to be 140 watts. In this case, power came out to be 140 watts. Direct, I would say, dot product of F and V. Now there is a question which was asked in JEE 2025 on this power concept. An object of mass 100 grams. Mass 100 grams means 1 kg because 1000 grams, sorry, not 100. 1000 grams means 1 kg. Experiences a time-dependent force. A force acts on it, that is 2t I cap plus 3t square j cap. This force. Find the power generated. We are supposed to find power. My dear NEET aspirants, we know power is basically the dot product of force and velocity, F dot V. But the problem here is we don't know the force. Problem in this case is we don't know the force. Okay. So we have to calculate the force over here and we have to calculate the velocity over it. No, force we know, force we have. And velocity we don't know, but we can calculate velocity. That is not a problem. Now see, my dear NEET aspirants, from force we can find acceleration. Acceleration will be force divided by mass. Now force is, I would say, 2t I cap plus 3t square j cap. Mass over here is 1 kg divided by 1. Now when you get the acceleration, boys and girls, when you get the acceleration, you can find velocity from acceleration. How? You can say change in velocity is integration of a dt. With the help of this equation, you can find velocity. Now, my dear NEET aspirants, I would say this change in velocity is going to be integration of acceleration is 2t I cap plus 3t square j cap into, I would say, dt. Into, I would say, dt. Now, boys and girls, delta V in this case would be 2t. So, it is going to be 2t square divided by 2 into I cap plus. And then this 3t square. So, it is going to be 3t cube divided by 3 because integration of t square is t cube by 3 j cap. Now, boys and girls, what I can say in this case, 2 and 2 will be cancelled, 3 and 3 will be cancelled. So, delta V came out to be, that is t square I cap plus t cube j cap. Now, we can write over here final velocity minus initial velocity is equal to t square I cap plus t cube j cap. Now, initial velocity, I'll be considering over here 0, boys and girls. Initial velocity, I'll be considering 0 in this case. Initial velocity, I'll be considering 0. So, final velocity, I would say that came out to be t square I cap plus T cube J cap. Now you can find the value of power. So power will be dot product of F and V. Force is here. This is force. This is velocity. Now do the dot product. Now here I, that is 2T. Here it is T square. Okay. Now tell me, 2T into T square is how much? 2T cube. Plus, here it is 3T square. Here it is T cube. T cube into 3T square. So bases are same, powers are added. 3 plus 2 is 5. So it is going to be, in this particular case, that is 3T raised power 5. This watts. 2T cube plus 3T5. Is this clear, boys and girls? Tell me. Is this clear? Come on. That's great. That's great. One more important concept I just want to mention over here, boys and girls. What is that? That is loss in kinetic energy. Guys, there are 3 types of collisions. Please directly remember this. In case of elastic collision, when 2 objects collide in elastic collision, we say kinetic energy before the collision is equal to kinetic energy after the collision. So my dear NEET aspirants, we say loss in kinetic energy is 0. And in case of inelastic collision, loss in kinetic energy is 1 by 2 m1 m2. m1 is the mass of first object, m2 is the mass of second object. Divided by m1 plus m2 into u relative square 1 minus e square. E square. E is the coefficient of restitution. So basically, my dear NEET aspirants, I'll make you understand over here. If this is mass m1, it is moving with velocity u1. If this is mass m2, it is moving with velocity u2. If they collide with each other, after the collision, they start moving with v1. This starts moving with v2. Now, if the collision is inelastic, this is going to be the loss in kinetic energy. And E is basically the coefficient of restitution. U relative means u1 minus u2. Next, my dear NEET aspirants, perfectly inelastic. In case of perfectly inelastic, we say loss in kinetic energy is 1 by 2 m1 m2 upon m1 plus m2 into u relative square. Directly, please remember this. Don't ask me where does these equations come from. Now take a look at this question. This is also a previous year question. An object of mass 80 kg. There is an object, its mass is 80 kg. Okay. There is an object, its mass is 80 kg. 80 kg. Is moving with a velocity 2 meter per second. It is moving with a velocity u1 is equal to 2 meter per second. Collides with another object of mass 20 kg. It collides with another object of mass 20 kg, moving with a velocity of 4 meter per second. So this is the value of u2. Find the energy loss if the collision is perfectly inelastic. In case of perfectly inelastic, this is the formula. So I would say energy loss, U loss, it is going to be 1 by 2 m1 m2 divided by m1 plus m2 into u relative square. Now, boys and girls, u relative means u1 minus u2. Okay. Now, what I can say in this particular case, u loss is going to be 1 divided by 2. Tell me, boys and girls, mass of first is 80. Mass of second is 20. Divided by 80 plus 20 is 100 into u relative square. U relative will be u1 minus u2, that is 2 minus, I would say in this particular case, 4. Collides with another mass of 20 kg. This has to be this another mass. Okay, it has to be like this. It has to be like this. Then they will collide. This is 20 kg mass. It is moving with u1. It has to be like this, 4 meter per second. This is 80 kg mass. It is moving with 2 meter per second. Okay, then only they will collide if they are moving in the same direction, because this velocity has to be more, u1, u2. Okay, so now tell me, boys and girls, in this particular case, this is going to be 4 minus 2 its whole square. Now tell me 0, 0, 0, 0. So this 2 and 2 will be cancelled. So this is 8. 4 minus 2 is 2 square is 4. 8 into 4. It is going to be 32 joules. Loss in kinetic energy came out to be 32 joules. 32 joules. I hope this is clear. Let's move on to the next one. Very important concept. One more. Now guys, this is also from the collisions. Let's suppose, boys and girls, if you release an object, in this particular case, listen carefully. From height h, it falls down and strikes this surface. With what velocity? UBC. What is UBC? Velocity before the collision. Velocity of the object before the collision. After the collision, basically, guys, when you release an object, it falls onto the ground. Then it goes up again. Not up to the same height. Then it falls back. Then again it rises. Then it falls back. Again it rises. Then it falls back. Again it rises. So this I am showing you over here. The same thing I am showing you over here. Ball falls, then it rises. Then again falls, then it rises. Now, boys and girls, this is velocity before the collision. This velocity is after the collision. When it strikes with, then again it goes up, then again it falls, then again goes up. Velocity after third collision. This is height after second collision. Okay. This is height before collision, height after first collision, height after second collision. This is height after third collision, and so on. Let's suppose, my dear NEET aspirants, if I say, in this particular case, let's suppose, my dear NEET aspirants, if I say it has done n collisions, what is going to be the velocity after n collision? Velocity after nth collision. Directly remember, e raised power n, velocity before collision. You can write it like this. This is the velocity after nth collision. E raised power n, velocity before collision. Velocity before collision is this. And if somebody says, what is the height after nth collision? Height after nth collision is going to be e raised power 2n, height before collision. Height before collision. You can write it like this. And my dear NEET aspirants, one thing I would want you guys to remember over here. This e, that is coefficient of restitution, you can find under root of height after collision divided by height before collision. Keep this thing in your mind. Keep this thing in your mind. Height after collision divided by height before collision. Okay? Yes. 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 Now, let's take a look at this question. Let's take a look at this question, boys and girls. Let's take a look at this question, boys and girls. In this particular case, my dear NEET aspirants, just a second, guys. Man. Okay. Now, guys, a ball is allowed to fall from a height of 10 meters. A ball is allowed to fall from a height of 10 meters. A ball is allowed to fall from a height of 10 meters. Okay. A ball falls from a height of 10 meters. Understand this very carefully, my dear NEET aspirants. A ball is allowed to fall from a height of 10 meters. Okay. And loses its energy. And loss in energy is 40% due to the impact. So basically, when it strikes with the ground and then it rises up to some certain height. Okay. So it says it loses 40% of its energy. It loses 40% of its energy due to the impact. After one impact, ball will go up by. Then it says how much height it will go up. Now guys, tell me one thing. In this particular case, can I say, what is the energy initially? At this point, what is energy? mg into h. mg into h. What will be energy over here at this point? Sir, energy at this point finally is going to be, listen to me very carefully, boys and girls. Listen carefully. Sir, energy at this point will be, it has lost 40% of its energy. So how much is remaining? 60%. So it is going to be 60% of initial energy. Energy at this point is 60% of initial energy. So I can say finally, at this height, energy is 60% of initial energy. Now, this final energy at this point, we can write it like this also, mg into small h, because here height is h, small h. Because at height h, potential energy is mgh. It will be 60% means 60 divided by 100 into mg into capital H. mg into capital H. Now m and m will be cancelled, g and g will be cancelled. This and this will be cancelled in this particular case. Now boys and girls, this height is also given as 10. So this h is going to be 6 divided by 10 into this 10. So 10 will cancel, so h will come out to be 6 meters. So basically, if it loses 40% of its energy due to one impact, it is going to go up by how much distance? 6 meters. One more question in this particular case. A rubber ball is dropped from a height of 5 meters. A rubber ball is dropped from a height of 5 meters. You are dropping a rubber ball from a height of 5 meters. Understand this question also. You are dropping a rubber ball from a height of 5 meters. You are dropping a rubber ball from a height of 5 meters. Height is equal to 5 meters. On the plane, where acceleration due to gravity is not known, on bouncing, it rises to 1.8 meters. After bouncing, after striking with the surface, it rises to a height of h dash is equal to 1.8 meters. Okay. The ball loses its velocity on bouncing by a factor of. The ball loses its velocity on bouncing by a factor of. Listen to me very carefully. Boys and girls, this question is very important. When an object is released from certain height, due to the impact, there is loss in velocity. And loss in velocity, guys, loss in velocity, please directly remember this. Loss in velocity, I would say fractional loss in velocity. This is fractional loss in velocity. What is the portion? What fraction of velocity is lost due to the impact? Fractional loss in velocity. It is E minus 1. Please directly remember this. It is E minus 1. This is the formula. E is the coefficient of restitution. Now, how can we find the coefficient of restitution? I have recently told you coefficient of restitution is going to be under root of height after collision divided by height before collision. Coefficient of restitution is going to be height after collision divided by height before collision. Okay. Now, my dear NEET aspirants, I can write it like this, under root of height after collision, that is 1.8. That is going to be 18 by 10 into height before the collision is 5. This is going to be 18 divided by 50. 2 25s are 2 9s are 18. Root 9 divided by 25, that is going to be 3 divided by 5. Now tell me how much is the fractional loss in velocity? I would say V loss. It is going to be E minus 1, that is 3 divided by 5 minus 1. So this is going to be 5 into 1 is 5. 3 minus 5 is 2 divided by 5. So minus 2 by 5. Minus 2 by 5 means 2 by 5. Negative means basically loss. This is going to be the loss in the velocity over here. Next concept, my dear NEET aspirants, is angular momentum. Next concept, my dear NEET aspirants, is angular momentum. Angular momentum. Now, boys and girls, if let's suppose I say you have an object over here, its mass is m, it is moving with a velocity v. Sir, if it is moving linearly, we say it has linear momentum. So linear momentum is P is equal to mv. Now listen carefully. If I say this mass m over here with respect to point A, it is moving with a velocity v. So with respect to point A, it is moving linearly, straight. So with respect to point A, body is performing translational motion. So it will have linear momentum, that is P is equal to mv. Now if I say with respect to point B, now point B, if you draw this R, it is creating an angle theta. With respect to point B, it is moving angularly, boys and girls. With respect to point B, body is moving angularly. So it will have angular momentum. So if an object is moving angularly with respect to some other point, it will have angular momentum. If a body is moving linearly with respect to some point, it has linear momentum. And that angular momentum is directly, remember boys and girls, that is mvr sine theta. When body moves angularly, angular momentum. When body moves linearly, linear momentum. Or we also call it R cross M into V. Okay. Or we say R cross P. Directly you can remember these particular formulas. You will be basically able to solve any of the questions out there. Okay. Yes, absolutely. 100%, sir. This is how we define angular momentum. Or if we say, my dear NEET aspirants, we can write it like this also. Let's suppose there is an object, its mass is m, it is moving with a velocity v. With respect to this point, which is at r distance, if you define its angular momentum, this angle is theta. Now this is r. This angle would be also theta. Now, boys and girls, in this particular case, you write angular momentum is equal to, that is mvr sine of theta. Listen carefully. If this is r, this is theta, this component of r is going to be r cos theta. This component is going to be r sine theta. So basically, this will be r perpendicular. Now tell me, in the angular momentum formula, which of the two components you are considering? Are you considering the perpendicular component, that component which is perpendicular to the velocity, or that component which is parallel to velocity? Perpendicular one. So you can say L is equal to mvr perpendicular. Means you always consider that component which is perpendicular to velocity. So velocity and r must be perpendicular to each other. Okay. One more important thing. If a body is purely rotating, this is called pure rotation. And if this body is moving, this is called angular motion with respect to this point. This body is moving with respect to this point, angular motion. This is pure rotation. In case of pure rotation, angular momentum is defined as I into omega. Tau is equal to I into omega. This is the angular momentum of purely rotating body. And L is equal to, let's suppose this is a body. I is what? I is moment of inertia. Omega is angular velocity. Like this is a rod. This rod has moment of inertia ml square by 12. Moment of inertia of rod about this axis is how much? Ml square by 12. And if it is rotating with angular velocity omega, so angular momentum will be ml square by 12 into omega. Ml square divided by 12 into omega. Let's take a look at the question which was asked in JEE 2025. Let's take a look at the question which was asked in JEE 2025. An object of mass m is projected from the origin in x vertical xy plane at an angle of 45 degrees. Now guys, see, you have launched an object something like this in a projectile motion at an angle of 45 degrees. Okay. With velocity v naught. With velocity v naught. Now, my dear NEET aspirants, the angular momentum with respect to the origin when it reaches the maximum height. When the object reaches maximum height, What will be the angular momentum? Its mass is m and velocity here would be. Listen carefully. If this is v, this component of velocity is going to be v naught cos of 45. Cos 45 is 1 by root 2. So this is going to be v naught divided by root 2. Now guys, you must remember at the topmost point, maximum height, object has only horizontal velocity. Vertical component of the velocity at topmost point is 0. So horizontal component is, I would say, v naught divided by root 2. V naught divided by root 2. Now boys and girls, listen carefully. This is going to be, guys, if this is the point, with respect to origin, you have to find the angular momentum. So this is going to be the perpendicular distance r. This is the r. This will be the perpendicular distance. And this, okay, and this is the velocity at topmost point. This is mass. Now this is r. Boys and girls, please listen carefully. This is going to be the r perpendicular. And r perpendicular is also called the maximum height. This is h max. So if you say, sir, h max in this particular case, maximum height of a projectile, maximum height of a projectile is, that is v u square sine square theta by 2g. So u square, u is v naught square, sine square of theta, that is sine square of 45 divided by 2g. Now this is going to be v naught square, sine square 45 is 1 by root, sine 45 is 1 by root, 1 by root 2 whole square is 1 by 2. So 1 divided by 2 into, I would say, 2g, that is 4g. So this is going to be v naught square divided by 4g. V naught square divided by 4g. Now tell me, boys and girls, what is going to be the angular momentum? That is mvr perpendicular, because this is what I have recently told you. So this angular momentum will be mass, velocity is v naught divided by root 2, and r perpendicular, boys and girls, r perpendicular is this h max, and that is v naught square divided by 4g. So this is going to be v naught cube, m v naught cube divided by 4 root 2 into g. This is going to be the angular momentum. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats, everybody out there. Guys, smash the like button if you are not like the session yet. Come on, do it quick. That's great. This will be the angular momentum in this particular case. One more important concept, that is called conservation of angular momentum. From this also I'm expecting a question. Conservation of angular momentum. Conservation of angular momentum is nothing but if net external torque on an object is 0. Listen carefully. If I'll just write over here. If net external torque on an object is 0, then angular momentum is conserved. Directly remember. Angular momentum is conserved. That means initial angular momentum will be equals to the final angular momentum. Initial angular momentum is I into omega. Final angular momentum is I dash into omega dash. This is going to be the conservation of angular momentum, nothing else. Like, there is a question which was previously asked over here. A thin rotating circular disk of mass m and radius r is rotating about an axis, passing through its center with omega. Boys and girls, there is a disk. Listen carefully. There is a disk. This disk, it is rotating about an axis. This is the axis, about this it is rotating. Its mass is m and radius is r. It is rotating with angular velocity omega. Okay. Then after that, if another disk of mass m by 2, there is another disk of mass m by 2, okay, is placed gently onto the first disk. Listen carefully. I'll make you understand. So this is the first disk which was rotating, m, and moment of inertia it has I. If another disk is gently placed on this one, which has got mass m by 2, so its moment of inertia will be I by 2. Mass is halved, moment of inertia is halved. Then it says the new angular velocity of this system, with what angular velocity it is going to basically rotate, omega dash, you guys are supposed to find out. Boys and girls, initially only one disk was rotating with angular velocity omega. Then after some time, you are placing one more disk onto the previous disk. What will be the new angular velocity? Here we say net external torque is 0. No net external torque is acting on this system. So we say angular momentum initial will be equals to angular momentum final. This is initial, this is final. Now tell me, initially moment of inertia of this is I. Moment of inertia of disk is I. Finally, boys and girls, moment of inertia of this plus moment of inertia of this, that is going to be I divided by 2 plus I. That is going to be 3I by 2. So initially moment of inertia is I, angular velocity is omega is equal to. Finally, moment of inertia is 3I by 2 and angular velocity will be omega dash. That is what we are supposed to find out. Now I and I will be cancelled. Take it over there. So it will be 2 omega divided by 3 will be equals to omega dash. This is going to be the new angular velocity, 2 omega divided by 3. Is that clear, boys and girls? There is one more concept I have, one more question I have put up on this one. What is that? That is this question. Please take a look. You would be able to understand this very easily. In this particular question, there is a table. On this table, you have placed basically, see what does the question say? A mass m moves in a circle on a smooth horizontal plane. There is a mass m which moves on a smooth horizontal plane with velocity v naught. Okay. And radius r naught. Radius r naught. The mass is attached to a string. The mass is attached to a string. This mass is further attached to a string, which passes through a smooth hole. Which passes through a smooth hole. Okay. In the plane as shown, the tension in the string is increased and the mass m is moved to r naught by 2. So basically this mass was rotating something like this. It is attached to a string which is passing through the hole. Now if you pull the string, this mass will come close. This mass will come close. At what distance? It will come close at a distance of, at what distance? I would say r naught by 2. Initially it is at r naught. So when it moves to r naught by 2, the final value of the kinetic energy will be. Guys, initially it was moving at r distance. What is the kinetic energy initial? You would be saying 1 by 2 mv square. Mass is m. V naught is the velocity v naught square. This is the initial kinetic energy. Now finally, my dear NEET aspirants, when it moves to r naught by 2, what is the final kinetic energy? 1 by 2 m. Mass is same. But velocity here we don't know. We have to find velocity. Do one thing, conserve the momentum. We say here, initial angular momentum is equal to find. When the mass was here, angular momentum is equal to, when the mass is here, it will be same. What is the angular momentum at this point? Guys. MVR, mass is m, v naught and radius is r naught. So m, v naught and r naught. MVR sine theta, theta is how much? 90. Because velocity and r are perpendicular, sine 90 is 1, will be equals to, when it moves to finally at this point, so it will be m, what is the velocity? V dash, and radius is r naught divided by 2. M and m will be cancelled, r naught and r naught will be cancelled, so v dash came out to be 2 times of v naught. So basically when object reaches at r naught by 2, velocity becomes double, 2 times of v naught. Now tell me, what is final kinetic energy? Sir, it will be 1 by 2, m is mass. Now velocity, what is finally velocity? 2 v naught square. Okay, so this is going to be 1 divided by 2. Mass is m. This is 4 V naught square. So 2 ones are 2 twos are 4. This is going to be 2 mv naught square. This is basically the final kinetic energy. This is the final kinetic energy of the system. Final kinetic energy of the system. Okay. Yes, I believe this is clear. I believe this is clear. Absolutely. Okay. Let's take a look at this particular concept over here. That is equation of continuity. Equation of continuity. What does equation of continuity actually say, boys and girls? It says whenever the amount of fluid enters the pipe per second, same amount of fluid must leave the pipe per second. Like it is a pipe over here. Whatever the amount of fluid enters this pipe, same amount of fluid must leave the pipe. Same amount of fluid. Sir, here, large amount of fluid will enter. So in this case, velocity will be less. Velocity of the fluid will be less. It will move slowly. Here, area of cross section is less. So velocity will be large. So fluid will come out with large speed. If pipe becomes narrow, the fluid must speed up. If pipe becomes wide, the fluid must slow down. So I can say in this particular case, A1 V1 is equal to A2 V2. So means this area of cross section over here into velocity will be equals to area of cross section here into velocity V2. A1 V1 is equal to A2 V2. Yes, absolutely. 100%. Absolutely. Now on the same concept we are supposed to apply over here. A large open tank of 2 holes in a wall. There are 2 holes in a wall over here. Okay. Okay. There are 2 holes in a wall. There are 2 holes in a wall. One is a square of side A. One is a square of side A at depth X. At depth X. From the top. And other is the circular hole of radius R. Other is the circular hole of radius R at a depth of 4x. At a depth 4x from the top. When tank is completely filled with water, the quantities of water flowing per second from both the holes are same. So the amount of water coming out of this will be same as the amount of water coming out of this hole. Then the value of R will be basically you are supposed to find the radius of this R. Guys, you are supposed to apply the equation of continuity in this particular case. Tell me, can you do it? Can you do it? First and the foremost thing. It says the amount of water which comes out of this hole will be same as the amount of water which comes out of this hole. And the velocity with which the water comes out, this is going to be V1 is equal to. Guys, the velocity with which the water comes out of the hole is called a velocity of efflux. And that is equal to under root of 2gh. H is the depth. So here it is going to be under root of 2g. G is the acceleration due to gravity. H is x over here depth. Here velocity with which it comes out, v2, it will be under root of 2g into 4x because this depth is 4x. Now we can use the equation of continuity over here. What is that? That is A1 V1 will be equals to A2 V2. Now area over here, my dear NEET aspirants, what is the area of this square hole? Side square A into A, that is A square. So this is going to be A square into velocity. Velocity is under root of 2g into x is equal to area A2. What is the area of this particular hole over here in this particular case? Can you tell me? Area of this hole, that is pi r square. Pi r square into velocity v2. V2 is under root of 2g into 4x. Now what remains over here? Guys, 2gx. Root 4 is 2. So a square is equal to pi r square into root 4 is 2. Okay, so take it over here, 2 pi. So r square will be equals to a square divided by 2 pi. Now instead of r, you'll be putting the root. Instead of square, we'll be putting the root. So this will be A divided by root 2 into pi. Root 2 into pi. I hope this question is also clear. There is one more question which I have put up on this one. Please do check this from your end. This is your homework. This one. Simple, simple. You can solve this from your end. This is not the difficult one. It is easy. Okay, absolutely. Okay, yes. Now guys, one more important concept I just want to make you understand. What is that? Listen carefully. That is viscosity. What is viscosity? We say viscosity is defined as the measure of fluid resistance to the flow. Measure of fluid resistance to the flow. Okay. Or it is a fluid friction, cohesive force between the two liquid layers. Guys, see. Let's suppose liquid is flowing. I'm taking two liquid layers. This liquid layer and this liquid layer. And the velocity of this liquid layer is V0. Velocity of this liquid layer is V0 plus delta V. Guys, if this object is sliding on my hand, means this object has velocity greater than my hand, then only friction is acting over here. If I say both are moving with the same velocity, what will be the friction over here? Nothing. Zero. So friction acts when there is relative motion, when there is motion between the two. So if this is having velocity more than my hand, then friction will act. Friction is there when there is relative motion between the two. Now see, this is a liquid layer. This has velocity more V0 plus delta V as compared to this. So friction will be between this liquid layer and this liquid layer. Now see, this object, this liquid layer, if it goes in the forward direction with respect to this, friction on the liquid layer will be in the backward direction. And boys, listen carefully. If you are inside the bus, you feel the trees outside the bus move in the opposite direction, but in reality, trees are at rest. So it is because of the relative motion effect. Same is the case over here. If this is the object, if this moves in a forward direction, so with respect to my hand, this phone is moving in the forward direction. With respect to the phone, this hand is moving in the backward direction. But in reality, phone is at rest. Same is the case over here. With respect to this surface, this liquid layer is moving in a forward direction. So friction acts opposite, backward. So with respect to this surface, this is moving in a backward direction. So friction on this will be in a forward direction. But in reality, this is also moving forward. But with respect to this, it moves backward. And distance between the two is L. Now, if somebody says how much this friction is being created between these two liquid layers, that friction is this one. F is equal to neta A, area of cross section, delta V, velocity divided by L, distance gap between the two. This is also called cohesive force between the two liquid layers, where neta is called the coefficient of viscosity. You can find the coefficient of viscosity like this also. Okay, now take a look. This is the question, previous year question of NEET. This is a previous year question of NEET. Now guys, take a look. A flat plate area 0.1 meter square is placed on a surface. There is a flat plate, it is placed on a surface and is separated by a thin film of oil. There is a thin film of oil. Okay, 10 raised power minus 5 meters thick. So where D is 10 raised power minus 5 meters thick, whose neta coefficient of viscosity is 1.5. The force required to cause the plate to slide on the surface at a constant speed of 1 meter per second is, guys, see. If I say you have to pull this plate in a forward direction with external force. Sir, Between this layer and this liquid layer, we say cohesive force will act. That is called a fluid friction that we recently studied. Now, in order to pull this plate forward with a constant speed, don't you think that the value of this force must be equal to this? Yes. If the value of this force is less than the cohesive force, you won't be able to pull it. So when this force becomes equal to this, then only you can pull it in the forward direction. So what is the value of this? This value of external force must be equal to this, that is neta, see, A delta V by L, neta A delta V divided by L. Now this force, external force, will come out to be neta. What is the value of neta? 1.5. Area of cross section. What is the area of cross section over here? 0.1. Okay. What else do you have? What else do you have? Delta V. With what velocity you are pulling it? 1 mm per second. You need to convert this also. Okay. In this particular case, if you have to convert 1 mm per second, how you guys are supposed to convert? Can you tell me in this particular case, my dear NEET aspirants? 1 mm per second in meters. Mm in meters is 10 raised power minus 3. So this is going to be 10 raised power minus 3 meter per second divided by L. L is basically this gap, that is 10 raised power 5 divided by 10 raised power minus 5. So please do check it from your end. What is going to be the answer of this? Next, similar type of question. I'm keeping you as homework on this one. Similar type of question. Similar type of question. Yes. Stokes law. This also is important. This also is important. Take a look, my dear NEET aspirants. Take a look, my dear NEET aspirants. Take a look, my dear NEET aspirants. It tells us the force on the solid spherical object moving in a liquid. Guys, see, you have a spherical object of radius r. And if you release a spherical object of radius r in a fluid, when it moves with certain velocity, that velocity is what we call the terminal velocity, Vt. And the force which is acting on it, opposition force which is acting on it, that is basically given by F is equal to 6 pi neta r Vt. Okay, r is the radius of the spherical object and this Vt is the terminal velocity. It tells us the force on spherical object moving in a liquid. What is the force acting on a spherical object moving in a liquid? This is going to be basically the force in this case. Directly you remember this. Now, the viscous drag means viscous force acting on the object on a metal sphere of diameter 1 mm. Diameter 1 mm. So diameter is given as 1 mm. Okay. So radius will be how much? That is 0.5 mm. Radius will be how much? 0.5 mm. So I can say radius in this case would be 0.5 mm. Okay, so that is going to be 0.5 into 10 raised power minus 3 meters. Okay. Falling through a fluid of viscosity is 0.8. 0.8. With a velocity of 2 meter per second. So this terminal velocity is given as 2 meter per second. Is equal to, we are supposed to find the viscous drag. Viscous drag means this force, 6 pi neta r into Vt. So F is equal to 6 pi neta r into Vt. Now directly you can apply these and you'll get the answer. See, another question of NEET 2022. The terminal velocity of a copper ball of radius 5 mm. Radius is given as 5 mm, that is 5 into 10 raised power minus 3 meters. Falling through a tank of oil. Falling through a tank of oil is 10 centimeter per second. So 10 centimeter per second is velocity. So centimeter means 10 raised power minus 2 meters. So 10 into 10 raised power minus 2 meter per second. The viscosity of the oil is, viscosity neta is given. The viscous drag will be again the question on the same formula. This is, I'll give you as homework. Same question on Stokes law. Same question on Stokes law. Absolutely, sir. Okay. One more important concept, that is acceleration due to gravity. Listen, my dear NEET aspirants, acceleration due to gravity. Acceleration due to gravity on the surface of Earth. Let's suppose this is Earth. On the surface of Earth, you have a mass m. A radius of Earth is, I would say, r. Mass m and radius of Earth is r. Now, if I say, what is the force acting on this mass due to the Earth? We know, sir, that is called gravitational force. That is g m1 m2 by r square. Now, if this is the force, what is the acceleration due to this force? Because when there is force, there is acceleration. So acceleration is going to be force divided by mass. When you put the value, so finally, this is the acceleration. So when gravitational force acts on it, due to the gravitational force, acceleration of this object on the surface will be gm by r square. Gm by r square. And in terms of density of Earth, this acceleration due to gravity would be this. G naught is equal to 4 by 3 pi. Rho, rho is the density. G is the universal gravitational constant. R is the radius of Earth. So these are the two formulas of acceleration due to gravity in this particular case. These are the two formulas of acceleration due to gravity in this particular case, my dear NEET aspirants. Okay? Yes. Now, in this case, acceleration due to gravity is directly proportional to r. So this is valid when density is constant. In this case, acceleration due to gravity is inversely proportional to r square. This is valid when I would say mass is constant. Mass is constant. So you can make the graphs also. Acceleration due to gravity versus r, this one. Acceleration due to gravity versus r, this one, inverse relation. So when mass is constant, inverse relation. When density is constant, direct relation. I hope this is crystalline clear. I hope this is crystalline clear. I hope this is crystalline clear. Like this is the question. Two planets having same density, when density is constant, the acceleration due to gravity would be, then in that case, acceleration due to gravity is directly proportional to r. So that would be great. That would be greater on larger planet. The one which is having the large radius will be having the large acceleration due to gravity. So my dear NEET aspirants, with this, we are done with the today's session. That's all for today. That's all for today. Thank you so much. Thank you. Now, boys and girls, listen carefully. Now, boys and girls, listen carefully. I would want you guys to do one thing. See. This is very important. This is very important. Right now, we are in this session. I want you guys to do one thing. See. This is very... Okay. Take a look. Take a look. First and the foremost thing, you go onto the channel and you subscribe to the channel. Okay. And when you subscribe to the channel, my dear NEET aspirants, you hit the bell notification. Okay. You subscribe to the channel. You subscribe. And you are supposed to hit the bell notification also. Okay. And one more important thing I would want you guys to understand. We completed this particular session. Apart from this, I would recommend you to watch. Wait. Please wait. Please wait. Please wait. Please wait. Please wait. I would recommend you to watch this session, this one. Do or die to get 130 plus. This I have taken previously. This one last stream. This one, 0 to 120 plus 2. This one, confirm 120 plus in physics, 3. And this one stream 100 marks. 100 marks guaranteed. This one, these 4 sessions. For sure, you are going to get 120 plus in your Re-NEET 2026 if you watch these 4 sessions along with the session which I have shown you today. Is that clear, boys and girls? Watch these sessions. Definitely you are going to score a lot. That is for sure. Okay. So take care and bye-bye. Thank you so much. Make sure you smash the like button. Take care and bye-bye. Thank you.